Example 5.3, let's consider the governing equation of 4.14. So I will write here the governing equation is m d2x dt square equal negative c dx dt minus kx plus pm sine wt. Which is given in problem 5.2 with boundary condition x0 equal to 0 and x1 equal to 1. So we have condition x0 equal to 0 and x1 equal to 1. So this is the equation. Find the approximate solution of equation 5.14 by shooting method, where the mass of the car m is given, the spring constant k is given, the forcing coefficient pm is given, the forcing frequency omega and c is also given. Use a step size of h equal to 0.25. Okay, this is important. We have to take note this, the value of h. With the first guess z0 equal to 0.5 and the second guess z0 equal to negative 0.5. Now in this question you are provided with the guess value, the first and the second guess value. So it's good. So before we continue, let's simplify the answer by substituting all the parameter values of m, k, pm, omega, c inside the equation. Okay, now let's write m is 1.5 times 10 power of 6. C is 1 times 10 power of 7 minus k x, okay, minus kx plus pm sine omega t. Okay, so let's make the second order derivative here as the function. So means that we want to move this to the right hand side. So each term can be divided by this value. Okay, so I will do like this. I will divide every term by this value. So the next line, you will obtain negative 6.6667 dx dt. Okay, minus 154.1333 x plus 16.6660 sine 0.5 t. So this is what you obtain after you simplify all the parameter value. Okay, so based on this problem, we want to use shooting method. Remember, shooting method has 4 steps. Okay, number 1, introduce let z equal to z is dy dx. Number 2 step is first guess, and we will solve by using Euler method. Number 3 is the second guess, and the last step is to do extrapolation. Okay, that is the steps that we want to perform in solving this equation. So let's start by step 1. Here we introduce let z equal to dy dx. But remember, our equation, our problem here is x to the t. So means that you have to know how to adapt. Your y actually should be replaced by x, and your x here should be replaced by t. That is what our parameter in this equation. So z is not dy dx, but dx dt. Okay, you must understand that. Now you will have two equations of first order, which is the first equation is the one that you introduced, but we just arrange so that dx dt become the function. We write like this, dx dt equal to z. And the second function is the equation from the problem. How to write? Okay, look here, we have d2x dt square this part. Actually this is d dt of z. Why I say like that? So let's substitute z. Z is dx dt. So when you calculate, you can see dd means d square, dt 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 square. This is the same. Okay, d2x dt square can be replaced by dz dt. So on the left hand side, on the right hand side, sorry, you just need to copy what it is. It's just the same thing. So this is your two equation, okay, and each equation should has their own initial value. For the first is dx dt, so you should have x0. Do we have x0 information, class? Okay, so you look at the problem here. You are given x0 equal to 0, so we just take from the information. Now for the second equation here, you have to give the first value of z0. You don't need to guess because the guess is already given. With the first guess, z0 equal to 0.5. So this is your your first guess. Okay. So this is step number 1. Okay, now let's move to step number 2. In step number 2, we solve the first guess. Here our z0 is given 0.5. And we need to solve by using Euler method. Remember the formula of Euler method is like this. Since your y should be replaced by x and your x should be replaced by t, so here I will write the original one, and then we can manipulate, we can adapt to our case. All right, I write the original one first. Okay, when we try to apply to our case, your x, remember here the transformation here, y should be replaced by x and x should be replaced by t. Okay, so your formula becomes x become t, so you have ti plus 1, right? H, what is your h? H is given in the problem. first step size, the step size is given as 0.25. okay, you can put this right away, and then y should be replaced by x, so this is your x. Okay, f1 can be replaced straight away. What is f1? Remember, this is the f1 and the whole line here is f2. okay, so f1 is just z. Okay, so zi times h is 0.25. okay, now z is just z is remain. What is f2? f2 is the whole thing, f2 times 0.25. okay, so that is the formula of Euler method that we need to apply in our calculation. So we want to construct the table. Table of iteration number, table of t, and we will have y and also z. okay, so your t, the first value of t is 0. Why we get 0? From the problem here. This is the first value of t start, and this is the value, the end value of tn, 0 to 1, with the step size of 0.25. So after you add 0.25, you will reach this, you will get this array, and I start from 0, 1, 2, 3, 4. So you have 4 iteration. Okay, then what is the first value of y? It's no longer y, it should be x. okay, what is the value, first value of x? From the given information, it is 0, and the first value of z is our guess. okay, our guess is 0.5. so you have to perform the Euler method by referring to this formula. okay, and then when you calculate, you will get this value. You can derive this. For z value, you will obtain this. Okay, after you finish the table, look at the last value. When t equal to 1, you will get this. So you can write your x when t equal to 1 is negative 0.4416. And what is your desired result? At the end point, you should have x1 equal to 1. Okay, is it equal to 1? No, so you put slash. It's not equal to 1.